Hey y'all, welcome back to Stationeers at the research lab, and it's time to show you guys how this thing is put together. It's not been very long since the other video showcasing this rig came out, but I got it to the point to where I'm happy and I don't think I can do it any better. We're gonna go ahead though, real quick lot, and not electrum. I want solder. We're gonna fire up solder. We're just gonna let it run so I can kind of show you guys what's what. And while that is queuing up, let's go back over here. Take a look at that. I love that. It's so cool. Anyway, this right here is where the furnace sits, the housing part for it. Now, this is a required piece of the build, putting it in here like this. Now, this piping network down here, I'm actually gonna move that one forward and stuff all this stuff in here. That just gives less area, less volume inside here. Although, I kind of built this with that there, so that might mess things up. That's something to think about. I might have to think about that. Now, this unit inside here is controlled to 250 kilopascals. And it's done so with this active vent and obviously that gas sensor there. Why 250? To nod to Venus, y'all. Venus love, that's the place to be. Back here, we got our hot tank of CO2 and our cold tank of CO2, which is extremely feasible. It's very easy to get those hot and cold tanks on Venus and doing it the legit way. Around this side over here, I am going to be able to condense this chip over here into the utility. It's just 2 pins. I have 2 spare pins left. I had it over here because I didn't exactly know what all I was going to do with it, but it turns out I'm done with it, so it's going to go into the utility and be part of that. That leaves us with this housing over here, which will control the LEDs and the diodes. Now, I'm going to leave it up to you guys. If I do LEDs and diodes, I'm going to need 6 pins because the LEDs and the diodes are displays for the 2 different tanks, the hot and the cold. The LEDs will show the total moles, and the diodes will show your progress that you have towards 30 megapascals. And speaking of that, there's 30 over there. Okay, I've already turned that off. I don't want anything to blow up. I think 50 megapascals is like the limit on the tanks, but we don't want to risk that, so we're going to keep it at 30. Now, there will be an atmospherics control that goes along with this script too, for Venus in particular, so that would be coming. I'm already working on that. I'm calling it the code box, which I've started experiments over there with that. And the code box is very feasible. It's very doable. Here I am talking away. Let's pop up here. Now we have the memory for solder set at about 400, which is kind of like a midway kind of deal. And we're shooting for 126 Celsius. And I have kind of an up and down, right? So maximum temperature that we will accept is 146 Celsius. And the minimum temperature that we will accept will be 106. And it tends to it runs more on the hot side of everything, which is fine. It's okay. I will set it so I might add a tag here while we're doing this, so you guys can just pick your offsets if you want a more tighter temperature control, but just be mindful, the tighter it gets, the more fuel it spins. Even though it's fueled by CO2, another nod to Venus, by the way, because there's a lot of CO2 on Venus. You know what I'm saying? Anyway, Venus is the best map, y'all. I love Venus. Anyway, we need to get in here to the ingot select. Let's go ahead and import it. Oh, we were already on it. Fantasticals. Let's go over this. This is the start of the build. I'm gonna try to cut out all the so's. When I think and talk, I tend to use the word so a lot. So I apologize. I'll cut those out as much as possible in post. Now the dial, the button, the furnace utility, and the actual furnace control. Those are the 4 things we have on our pins and that we're going to be monitoring. Our only alias in this one is the hash And like I had said in the other video, this is pretty much right out of one of Mick's IC tutorial classes, whatever you want to call them. By the way, if y'all don't know who Mick is, he is the guy over at Cows Are Evil. He has an amazing tutorial system on how to do IC programming. Sorry, y'all, if the headset moving thing was heard on the mic, I'll try to fix that too. But y'all need to go over there, check his channel out. He's the one who taught me code. And if he can teach me, fam, listen to me. He can teach anyone how to do this. Getting into what this particular IC code does is we have our dial and we have our button. That's our fire button. The fire button has a system that goes to a utility loop. So it's a branch if greater than, whatchamacallit, absolute greater than 0. So hit a fire if we press that button, and it'll pop us down here. And then we're going to be saving the setting of R0 into housing of the utility, the furnace. Now, what does that mean? If we come over here and we look at this housing, we actually have the hash code for solder. Now that's important later on because that's what's going to kick everything out down here. Now if you look at this one, the utility, its state is -1 and this one is state 10. We come over here and look at the dial, that's state 10 right there. And this is important later on. You see what I mean by the fuel? It's kind of wasteful in the fuel. It can't quite stabilize, but it's a lot better than it was before. Basically what this whole script does is give us a hash to work with so that we can auto spit out. So if we're doing iron, it'll spit out iron when iron's ready. But if we're doing steel, it won't spit out the iron. It'll only spit it out when it has steel. That's very important. It's the whole theme behind this is to be able to do that. I didn't want to set it. I didn't want to have a system where I had to manually do anything. The only manual thing I want to do is put the ore in and push a button. And I guarantee you when I get better at coding, I only have to do that. I can just put the belt somewhere in my base and it will wind up in the furnace. Figure out what it needs to do and do that. If that's possible. We'll find out. We'll find out. But that pretty much sums this one up. And then the final part to all that is the shutdown. And all that is when the setting is, when the dial is on 0, it pops down here and changes its housing setting to 0. And that's just so I can get a 0 state and basically have a blank picture over there. It's really all that is there for. For example, we come over like this, it's on 0, so there's no hash, there's nothing to compare it to. Everything is good to go. Let's put this back up here on 10. We don't really need to, but hey, we'll put it up there. Actually, you know what? While we're here, let's go to 16. Is it Ingvar? Or Incantel? I mean, yeah. I'll show you the bouncing of the pressure. The pressure I got pretty good because the formula for the pressure was explained by Mick, so it was really easy to understand and follow. It's the temperature that I have challenges with because I had to get the formula for that off the freaking Stationeers wiki. And yeah, that's what I meant by I understand the math to a degree. That's about it. But hey, you know, it goes to show if I can do this, you all can do this. Now this is the utility one here. And we have the desired temperature, the desired pressure, the device hash. Well, by the way, these D's mean device. I'm so clever with naming. I killed myself. The hash is the ingot select housing. Obviously, this right here is the actual furnace. And then the dial, I think that's leftover code from something because I wanted it to do a different thing instead of basing it off the dial. So this can actually get wiped out completely, just like that. Like I said, I haven't been in here in a while since I kind of modified this to do what I wanted it to do. Okay. So at the beginning of a loop, we're going to have the housing for this unit to be -1. Now this is where a trigger comes in. We're also going to be forcing the furnace handle slot to 0, which means that it just closes it if it was ever opened. And then we're going to immediately do a jump and return down here. So we're going to load the hash from the ingot select housing and the furnace. And then we're going to load, oh wait. Yeah, I did need that, didn't I? Alias device, dial D4. Okay, so maybe I was wrong. It happens. I haven't looked at this in a while because I've been spending so much time on the furnace part. Now, it's going to load the dial setting into R4. And this is all important right here, because first we're going to get a true statement from the hash and the furnace. So if both have the same hash rating, then we will get a 1 right here. Then we're going to save greater than of R4 and 0. If the dial is set at 0, this will give a 0 or a false, ever how you want to say it. So when we come down here and we ask, is R5, which is the true statement for these two up here, is that also equal to the true statement we got from here? So if it's in the flush state, it's going to say no, and it's going to set the open to close. But if it passes all of this, then that means that whatever we're wanting equals what's completed, and hit an open and automatically spit out the ingots for us. Now over here is the trigger state, and the trigger state comes after the auto eject. We're going to yield, which means we're just going to pause for 1 game tick, and that gives us a little bit of breathing room, because we're going to go down here and then we're going to load the dB setting into R0. Normally this would be -1, so that prevents this from continuing on, so it just forces us into this loop. However, once you press the fire button, it's going to go above 0, so that's going to allow us to come down here, and then we're going to be able to load, or we're going to jump relative to whatever the dial was when it was pressed. So if it was 1, it'll be here on basic. Now, one thing you can do is you can just replace all the basic ones with steel, because it's literally the same thing. In actuality, you can just have steel, electrum, and all the basics in just one thing, and it would save code, but don't really need to do that. So that's why I separated everything out. And basically, you know, if we want invar right here, hit a jump to down here where invar is. Where is it at? Right here. And then it loads into the memory units, the desired temperature and desired pressure. So that's how we get those. And then they're individually set for whatever it is we're after. Now that we're over here, we can kind of look at the pressure state. What we want is 23.5. And as you can see, it hovers right around that area pretty well. Let me go back up here. We were for ink and tail, because we need 23.5 to fire to get the ingot ready, and then it'll drop back down and it goes back up, but it's pretty tight. I'm happy with that. I can live with that, because I can just make batch after batch after batch. Now let's go over here to another interesting one, which is Hastaloy. We'll let that fire, we'll let that load up. Let's go ahead and just get this ready to look at here in a minute, because now that we've done the utility, let's go down to the coolant support system for this whole rig here. And this is the fun part right here. This is where I had to get a little creative, along with a lot of headache. We have a lot of aliases in here. I won't go over all of these, but they're right there for y'all to look at. We are batch loading, or yeah, we are batch loading the mixers in here. And it's not really because I didn't have the pins. It was simply just so I could get used to using code, you know, using loading batches and all that other stuff and saving into batches. That's a different beast all in its own. So it's good to get used to it. This one, this one right here. Let me tell you, fam. This took a minute for me to figure out. A hot minute. Oh God, like I've been working on this for 2 weeks. This advanced furnace setup. It fried my brain. But we need to get our temperatures from the hot tank and the cold tank. We need to get our total moles from the hot tank, and we need to get our pressures from the hot and cold tank. And then we also need to load in the setting from the logic memory and get that into our desired temperature. And then we need to make a high and low, like a, yeah, like no higher than this, no lower than that, but please try to get to this number. So that's what we got here. The next thing we need is we need something to compare everything to. And I like to call this the extreme shift. If the furnace temperature is lower than the low temp, then we jump down here to temperature low. And temperature low means that we're pumping in 99% hot air and 1% cold air. Now the flip side to that is if the furnace temperature is higher, right, than our high temp, then we're going to jump down here and we're going to pump in 1% hot, 99% cold. That's the extreme shift. Now, for the most part, this only happens in the very beginning. So this isn't something you normally see. It's either one or the other in the very beginning, and then it doesn't really go through this all that much after that. But here is the part that really broke my brain. Now, on the wiki, there is a page called pressure, volume, something, something, something. It's on the Stationeers wiki. And it basically gives you a formula to calculate temperature from the quantity that's in the unit. Well, I need to get the quantity from both things, sorta. So to do that, we're going to take the cold pressure and the hot pressure and subtract them. We're going to store that into R11. Then we're going to multiply that value against the total moles. And we get the total moles from the hot tank, because the hot tank is the most used tank in this whole system. So then we're going to take that number and we're just going to set it off to the side for a little bit because it is stored into R0. Now, the next part about this is we need a constant, and the constant is listed in the wiki. So we're going to multiply the constant by our desired temperature. We're going to store that into R13. And then we're going to divide R13 into the R0 that we got from the two pressures and total moles. Now, normally it would stop there, but I'm a little off on my equation. I'm not sure where. So growing up, I was always taught that if it ain't working, you just kick it until it starts working. That's what my old man always told me. So how in the world do you kick a math problem? Well, you add to it. That's my grand conclusion, was adding to the math problem. So after 82 kicks, I hit the sweet spot. So basically, I just took that number that we got from the pressure, volume, whatever quantity formula from the wiki. It's just really hard to understand on that because it's all this science and P equals MC squared to the minus. In other words, what that means, I am now, fam, a mathematician. Listen to me. I have the mad skills on the calculators, yo. This just goes to show you that if a country boy like me can do this, y'all can do this no problem. But it just took some finagling, and I got it done. Next, we need something to compare that to. So we're going to load the maximum setting from the pumps, store that into R14. Then we're going to compare that number and we're going to branch if it's equal. So if it's equal, we're going to pop back up to the start. But if it's not equal, we're going to go ahead and save that number, the pump setting, into all the pump. Now, this is what pretty much controls the temperature for the majority of the time. You see there, we've almost completely stabilized over there. If we come back around here, we should see that we don't have such a drastic shift because we've calculated how much the temperature of these two things, and I've done it that way because, you know, your coolant tank may not be 0. You know, it may be 20, maybe 30, maybe 100. So I want to take in consideration that temperature shift for people. Play it on different places. You may have like a different requirement you want to have your coolant tank as, although the perfect number would be 20. All of this testing has been evolved around about 0, so 0 is pretty much what I'm going to go for, but it should theoretically work with that formula that I got off the wiki. Should work with anything. You also may have to, you know what, I might also add an alias in here for the kicker, the kicking number, and let you guys be able to set that without having to go through all the code there. Oh yeah, speaking of all the code, I don't know if I said this or not, but right here is this 20, that's just a number I picked. What I might do is go up here and put some defines in, and we can call this like offset. We can call this, you know, the kicker, and then you all will be able to change those numbers at the very top up here without having to go dig through the code. But that's pretty much the gas control unit. Now we're going to move on to the furnace, not furnace utility, but the furnace part right here. This one was actually a lot easier to write because of mX, and it made it super simple. Now, going over this part here, we have our temperature and pressure. Those are the two logic memory chips. We have our shutoff lever and the furnace. And then obviously we got the pump and all the 3 pumps in the dial. They're on batches again, so I can just practice with code. And also there's only 2 chips left and there's 3 items here in total. So yeah, that's the thing. These are all of our aliases, very standard, you know. When you export this code and you have your furnace turned on, you know what? I might encase the furnace later on. So let's save. The heck did I call? Oh yeah, advanced furnace, ADV. Saved advanced furnace. It's set in for 1. That way, if you encase it, which is what I'm thinking about, completely encasing it inside a wall, then it will just automatically turn on for you without any problem. Okay, we're going to come down. We're going to reset the temperature. We're going to reset the pressure, keeping those at -1 states. This is basically the flush state. We have the output set to 500, and it's just going to run through this idle state completely. Now, whenever you hit the fire button, it's going to load that over here. Currently, without hitting the fire button, this is -1. So when we get down here to our branch statement, we just pop right back up here to the idle statement because we are less than or equal to 0. So it's just going to pop up here. But as soon as you hit that fire button, it's going to let us go into this next line. So we're going to change the output setting up here to 0, and then we're going to move into the active state. Now in the active state, we have right off the bat, the very first thing here is our flush state, which basically comes down here, sets the dial to 0, sets all dials on the network to 0, and then just jumps back and puts us back into the idle state. That only happens if it's open, and then when you pull the lever, once it goes back into the idle state, it just shuts the lever automatically for you. Now, down here, we need to load our temperature and pressure, and then here are the offsets again. I don't know if you've noticed the trend, but 20 was the way that I went. I think I was writing this while I was listening to a video of Mick. I think he was can't remember what he was doing. I think he was starting to work. I think it was when yeah, it was when he had converted to the new settings of Venus, right? And he said something and I swear it sounded like 20, but it wasn't. So that's pretty much where the 20 came from. Kind of a nod to Mick since his mind is what fueled my ability to create this, and his math is all over this everywhere. Now, here's a pretty simple part of this. We're going to get our um, temperature and pressure for our current so that we can monitor that. We're going to compare the desired pressure, which we loaded in up here from the memory unit, and if it's under, we're going to go down here, pressure under. And we're going to set the output setting to 0, pump on, input setting to 500. Just get all that beautiful pressure in there, and then we're going to pop back up here to the active state and go through it again. And then if it comes down and it hits overpressure, we're going to pop down to the overpressure setting. We're going to turn all the pumps off, the input to off, and then we're going to do the math. Now, this is a formula that Mick gave out in his Building a Better Furnace series, those 3 videos. And it's basically desired pressure divided by desired temperature times current temperature. I think he said that's the old gas formula, PT. So I can't remember exactly what he said, but yeah, that's where this came from. I modified it slightly so that then I turned it into an absolute value, and then I basically condensed it with this min thing. So the maximum setting that the output can be is 10. And it fluctuates, from 1 to 10. It'd be 1, 7, 2, 9, 3, 10. It fluctuates as needed, and that's what I needed. I needed a more precise control on the pressure out, which is mainly for ink and tail, which is why that was there. Coming back up here, if it passes all of that, we're going to check against our high temp and our low temp. And if one of those returns a 1, then we're going to go to the input state, which is right here. And this is another very simple calculation, and I got this from Mick also. We're basically going to turn the fuel pumps on, set the input to 500. We're going to divide our current temp by our desired temp, store that into R0, get the absolute value, and then do a min setting between of 100s input state, and then we're going to do a controlled output state. And then we're just going to jump back. And basically that just repeats on loop in the active state until we pull the lever. And then the final part, and this is what I'm going to condense in somewhere where I have the control support. If I have the space for 2 pins somewhere, which I don't know if I do or not, but this is just a simple code. We set our active vent to mode 1 so that it pulls air out. We max out the settings so that it pulls a lot of air out, and then we set its internal sensor to 250 kilopascals. And then we have a sensor over here that just turns it on if it's over 250. So if for some reason the pressure ever gets over 250, that'll happen. But let's take a look at Hestilloy here. Hestilloy has a really awkward temperature range. It's kind of tight, but kind of not. And as you can see, we've pretty much stabilized fairly well for this one too. We're still spinning it out down here though. As you can see, we're still in 10 liters, 500, it goes in and out. My system isn't perfect, and I do use a lot of my CO2 fuel for everything. I was thinking maybe adding more pumps back here, but I'd have to redo some of the formulas for that, so that might not be something I do for a while. But yeah, fam, that's it. It's very easy to build, survival ready, like I said. The only really expensive things in here to have a lot of is all this insulated stuff. Whoa, that exhaust over there. I have all these insulated pipes everywhere, and these these large tank takes 5 kits per, so that's 10 kits right there. But by the time you're ready to jump into an advanced furnace, you're good to go. However, there is a downside to my system. My system does require a functional um, atmospheric system set up. So if you're on Venus, you're going to have cold and super hot atmospherics base to prep these tanks, which is completely doable. Like I said, I've already built my ice box, and I'm working on a hot box, which probably going to just use the same system over here for a hot box and just kind of combust into a pipe and just filter that out. And I'll probably just use straight up hydrogen and oxygen. That's a thing that I currently have a lot of in my Let's Play. So probably what I'm going to use. But I hope y'all like this. Like I said, the formulas, you can get everything you need off the wiki. And not only that, you can get everything you need and then some over on the channel Cows Are Evil. Mick will teach you a lot. Also, the wiki and the Stationpedia is loaded with information on how to do things. So don't be afraid to jump in, y'all. This was a daunting task when I first started, but getting started is all you need to do. And then you can pretty much go to the Wikipedia, or even in some cases the Stationpedia, and just get the information you need. Like when I was working on my gas system, I was like, well, how in the world do I calculate how much goes in and how much goes out? Heck, I just Googled freaking Stationeers gas formulas, and it took me to the wiki, and they have examples on there. They have all kinds of stuff. A lot of information has been put out there by a lot of great people. A lot of dedicated people really like this game. It's a fun game. It does take some brain power, which goes back to be saying, if I can do it, you all can do it. Because yeah, that's the thing. But all right, y'all, I really hope this inspires some creativity. Coming from a person who basically has limited to okay levels of IC knowledge. I'm still very new at this, but I took what knowledge I gained from Mick, applied it to a problem, and created this. This is my masterpiece in this game so far, and I'm super proud of it. It's not perfect, it's wasteful, but it gets the job done, and I couldn't be happier. So, with that being said, I am going to enjoy my time on Stationeers. I hope you enjoy yours, and I will see you next time on Stationeers.